The purpose of this video is to explain how high-performance computing has given engineers new tools in fields of numerical simulation such as computational fluid mechanics. I will also explain what the best sort of HPC systems are to make use of for these sort of simulations. But let me begin by showing you an example where HPC has had a noticeable visual effect on the design of an aircraft. The Lockheed F-117A Nighthawk, the original stealth fighter on the left, first flew in 1978, while the Lockheed F-22 Lightning, the current generation of stealth fighter, first flew in 1992. Both of these aircraft have the property of being stealthy, that is to say nearly invisible to normal radar. Engineers achieved this by calculating the amount of radar reflected back to the receiver by means of an electromagnetic simulation program on a computer. As many of you will know, a three-dimensional curved surface may often be approximated as a series of triangles for purposes of simplicity when making a computer model. Back in 1978, the number of triangles that a computer could handle was not very large, and the result is that you can see the individual triangles on the aircraft. By the early 90s, when the F-22 first flew, engineers had much more powerful computers at their disposal and were able to simulate tens or even hundreds of thousands of triangles in order to approximate the surface of a fighter. And that is why, while the F-117 is made up of triangular facets which are clearly visible, the F-22 is all smooth curves. Today, computers can handle tens of millions or even hundreds of millions of triangles for similar problems. These sorts of electromagnetic simulations are used for more peaceful purposes, such as designing radio telescope dishes, and, more mundanely, even cell phone antenna. You may be watching this on a cell phone now using an antenna that was designed on a supercomputer. In addition, engineers have other simulation tools at their disposal. For instance, structural analysis using finite element methods can be used to determine whether a beam in a building or the walls of a pressure vessel are strong enough to withstand the forces acting upon them. And then there is my own field of research, computational fluid dynamics. This is used in everything from aircraft and Formula One car design, ship design, to process engineering applications, for instance designing paint-making machinery, and even modeling the blood flow through blood vessels in the human body. Without all of these numerical simulation tools, it's fair to say that engineers today would be a lot less capable and would not be able to achieve some of the wonders which we take for granted in the world around us. So how did engineers cope for most of the 20th century when they did not have electronic computers to do their simulations for them? Let's go retro for a moment to find out.
When the high-speed flight research program was initiated during the closing days of World War II, aerodynamic theory had been able to predict, and wind tunnel experiments had been able to visualize some of the problems associated with compressibility. This sequence, taken in a wind tunnel by means of a...
Engineers and aerodynamicists still use experimental tests in the lab or wind tunnel today, and probably will for the duration of my life. A small-scale model is placed in the wind tunnel, and the results are interpreted using mathematical scaling laws in order to apply them to large full-scale aircraft or cars. The problem is that the scaling laws are not universally applicable, and it is therefore sometimes necessary to test a full-scale prototype instead of a model. In the case of a car, this is not so bad, but if you're testing a full-scale aircraft in the wind tunnel, you need a very large wind tunnel indeed. The operational costs for such an enormous experimental facility are of course massive. In the next video, I will explain the mathematics behind the numerical simulations which made redundant wind tunnels such as the giant Langley wind tunnel of NASA, which was finally closed down in 2008.